Cellular telephone systems are designed to provide two-way voice communication at a vehicle speed with the regional or national coverage. Cellular systems were initially designed for mobile terminal. Cellular systems basically they have the initially designed for the mobile terminal inside the vehicle with the antennas mounted on the vehicle roof. So what is cellular telephony? Mobile telephony is often called cellular telephony, and mobile phones are called cell phone because of the structure of the wireless network in the which mobile phone operate. The network is divided into cells, which each phone is connected to the exactly one cell at any given time. What is the introduction of cellular communication? Cellular communication is a form of the communication technology that enable to use of mobile phone. Mobile phone is a bidirectional radio that enable simultaneous transmission and reception. Cellular communication is based on the geographic division of the communication coverage area cell and within cell. What are the characteristics of cellular telephony? They offer a very high capacity in a limited spectrum. Reuse of radio channel in different cells enable the fixed number of the channel to serve a arbitrary large number of users by the reusing the channel throughout the cover region. What are the uses of cellular telephone? Mobile phones are used in the variety of the purposes such as keeping in touch with family members, for conducting business, and in order to have access to a telephone in the event of an emergency. Some people carry more than one mobile phone for different purposes such as for business and personal use. Why is it called cellular telephony? So they detect the diagrammatic network of wireless towers into what they call as a cellular layout. Cellular was the chosen term because each tower and its coverage map looked like a biological cell. Eventually, phones that operated on this type of the wireless network were called cellular phone. What is cellular communication called? These are the two kind of the cellular communication. Communication between cells is called intracellular signaling, and communication within cell is called intracellular signaling. Why is cellular communication important? Cells of all multicellular organisms need coordinate for the remote. This is the image for the cellular telephone system, an overview. This is the base station, and they are connected with the one cell is connected to the another cell, one cell, and every is connected to the computers. Now you can see this like a mobile telephone switching office, toll office, local office, tendency office, local office, cell cluster, channel cell, and more. What is the frequency reuse mean? You can see this diagram: frequency reuse factor, cluster size, and then the cluster. This is the frequency reuse, and they are related to cluster and other. What does frequency reuse mean? The ability to use the same frequencies repeatedly across a cellular system, as each cell uses radio frequencies only within its boundaries. The same frequencies can be reused in other cell, not for away, with a limited possibility of interference. The handoff strategies in mobile communication. When a mobile move into a different cell while conversation is in the progress, the MSC automatically transfer the call to the new channel belonging to the new base station. This process is transferring the channel between two cells is called handoff. These handoff strategies in mobile communication not only involve identifying a new base station but also require that the voice and control signal be allocated channel associated with the new base station. This include mobile and wireless communication on the various handoff strategies in mobile communication like gate and in the like handoff strategies. The handoff is an important task in any cellular radio system. The handoff must be performed successfully and as infrequently as possible and be imperceptible to the user. In order to meet these requirements, system designer must specify an optimum signal at which initiate and hand off. This margin is given by cannot too large or too small. If it is a large unnecessary handoff which a burden to the MSC may occur to the too small, there may be insufficient time to complete a handoff before a call is lost. Demonstration of handoff stages. This figure demonstrates the handoff is not made and signal drop below the minimum acceptable level to keep the channel active. This drop at call event can happen when there is a expensive delay by the MSC in assigning the handoff, or when the threshold is set too small for the handoff time in the system. Excessive delay may occur during the high traffic condition, or due to no channel are available or any of the nearby base station. You can look at this example handoff in wireless mobile networks. One station, second station, and this is the MS channel which transfer the message from the one station to another station. This is the before handoff and this is the after handoff. So base station 1, base station 2, and had the handoff between MS and BS4. So in the deciding when to hand off, it is important to ensure that the drop is in the measured signal is not due to the momentary fading and the mobile is actually moving away from the serving base station, but when there is a drop in the measured signal level due to momentary fading and not due to the actual moving mobile away from the base station. That is the situation. If the handoff of a call takes place, then such a handoff must be prevented by ensuring that the base station monitor the signal level for a certain period of the time before the handoff is initiated. Factors on which a handoff depend. The time taken in deciding about handoff depend on various factors like transmitted signal strength. The signal strength is fluctuating very rapidly. The number of the handoff increases. Vehicle speed, the length of the time needed to decide if the handoff is necessary. This also depend on the speed at which the vehicle is moving. If the slope of the short-term average received signal in the given time interval is steep, the handoff should be made quickly. Co-channel and adjacent channel interference in mobile computing. Co-channel interference is not actually an interference but more a sort of the conjunction when more than one device is operating on the same frequency channel. It hinders performance by the increasing the wait time as the same channel is used by different device. Source of interference therefore like another mobile in the same cell, the ongoing call in the neighbor cell when a different base station operate on the same frequency. The types of channel on which interference is present are on-voice channel. This lead to the crosstalk, which is an interference or background noise while we are talking to another person or mobile. Crosstalk is unwanted interference that should be minimized. Number second is on control channel. It can lead to the problem in creating a connection between the sender and receiver during the call, which lead to the missed calls. Call may terminate abruptly, known as a blocked call. Interference caused the above two problems, on voice channel and on control channel. Interference causes these problems because it's reduce the channel capacity and thus affect the performance. Types of the interference in the mobile communication: co-channel interference, adjacent cell interference. Co-channel cells are those cells that use the same frequency in the given coverage area. Interference from these cells is called co-channel interference. In co-channel interference, the cells are clustered as close together as possible to reduce the co-channel interface and provide sufficient isolation. Increasing the co-channel reuse ratio improve the transmission quality because of the smaller level of the co-channel interference. An example of co-channel interference is what a radio transmitter is operating on the same frequency. So cell cluster is there and physical distance between co-channel cell. The reason behind co-channel interference are bad weather conditioning, poor frequency planning. We can reduce the co-channel interference in the cellular communication are proper planning and implementation. The frequency reuse technique increase the overall system capacity. Adjacent channel interference, it is the interference caused to the signal which is adjacent in the frequency to the desired signal. Imperfect receiver side filter allow the neighboring signal to mix with the actual passband. If the adjacent channel signal's strength becomes strong, it will be difficult for the base station to differentiate the actual mobile signal from the strong mobile signal. For understanding better, you can see this image where you have a signal or adjacent channel, the response here, and a signal or adjacent channel, and interference designed signal interference and the filter. Now the reason behind the adjacent channel interference are due to multiple channels close to the each other communicating using the signal frequencies. Irrelevant power emission from an adjacent channel. Factors for reducing adjacent channel interference like proper filtering, careful channel assignment, managing the space between two adjacent cells which should remain constant. Mobile phone PCB diagram. So if you see this diagram, you have a network section, power section, and with that you have the antenna point in the upper of the mobile phone, and on off switch where you can on the mobile phone, off this mobile phone, antenna switch and RF filter. You also have the network IC and BSI, BCO, audio and video, flash IC, RAM, ROM, UI module, logic, buzzer interface in the down, MIC interface, R22 CPU. You have a charging cable, charging IC, the power IC and RTC. Here if diagram showing the basic working principle of mobile phone. Antenna here is there, and speaker you have buzzer and RX that BCT and band pizza filter that connected with the signal in the audio form, and the place with the RAM. Now try to understand the timeline from the 1G to 5G, a brief history of cell phones. From 1G to 5G, the history of cell phones and their cellular generation. The timeline and history from 1G to 5G look just over 40 years since the introduction of wireless cellular technology, and a lot has changed since then. Cell phone has become smaller and become faster. Text messaging has come almost gone. Surfing the internet with the phone become common. This stream of social media posting continues, and apparently there is an app for nearly everything now. So the timeline from 1G to 5G couldn't have happened without the creating and enhancing each generation of the telecommunication, the leading to what is today. Roughly every 10 years since 1979, each newer generation has changed how we communicate, further improving our way of life. Diving into the abyss of the information, let's take a look into the timeline from 1G to 5G. Briefly looking at each generation to find out what it had to offer, we will also look the most popular cell phone user during the time. 1G launched by the Nippon Telegraph and Telephone in 1979. 1G was first introduced in the citizens of Tokyo by 1984. The first generational network covered all of the Japan, making the first country to have 1G service nationwide. It was not until March 6, 1983 that Ameritech introduced 1G to the United States. Soon after, Canada got coverage in the mid 1980s. Although the cell phone prototype was made in 1973, 10 years before the North America launched 1G, Motorola introduced the first commercially available cell phone to the public in 1983, the Dyna TAC. Now you can see this how the 1G phone was looking like. So the bagging in 2 pound, the Motorola Dynatec provided 30 minutes of talk time to took roughly an hour to charge. Nicknamed the brick, the Motorola Dynatec was valued at 3,995 US dollar, 10,300 today. Although being a clunky bulk and awkward phone to use, Dyna TAC sales were more than expected. Within the first year alone, Ameritech sold roughly 1,200 Motorola Dynatec phone. By 1998, cell phone and similar service accounted for two-thirds of Motorola. You can see this image if you want to see the how the Motorola phone was used. This was the phone. This is a 1G phone where now we are using 5G 4G technology, and that time the people was using 1G in the 1980 of the Motorola Dynatec commercial. Now, although being a revolutionary technology at a time, 1G suffered major drawbacks from the today's standards. Listening to somebody over a 1G network was difficult due to the low sound quality. Coverage was also shoddy with a large amount of the static noise and background crackling. No roaming support was provided either. Security didn't exist over a 1G channel because there was no encryption, meaning anybody with the radio scanner could drop in a call. Download speed over 1G was also incredibly slow and only reached around 2.4 kbps. Although progressive for its time, 1G still had a lot of the room for growth. So 2G, following the success of 1G, 2G launches in the global system for mobile communication. Global System Mobile Communication Finland in the 1991. 2G provided significant mobile talk advancement, introducing the encrypted call. Nobody could drop in your call unwanted anymore. 2G also improved sound quality, introducing static and crawling noise while you were talking. 2G download speed were also significant faster than 1G, averaging at 0.2 Mbps during its lifetime. 2G network also allowed us to transfer data bits from one phone to the another, enabling access to the media content and cell phones such as now transfer data. 2G also gave us some basic smartphone functionality. However, that was not the most state of the art benefit of this data transfer feature. In fact, 2G data transferring completely changes how we communicate by introducing text message and multimedia message MMS as a new form of the communication. You can see this candy bar phone also become popular during the 2G. Nokia in the lead for Nokia 3210. So this is the size of the Nokia 3210, and this was the 2G phone, considered one of the most compelling cell phone Nokia ever built. The 3210 model sold over 160 million units. So as testing, downloading and talking over the phone become more popular, the 2G network led to massive adoption of the cell phone on both the consumer and business side. Yet as more people began using cell phone, the demand of the data snowballed. Then 3G came, deployed for the public in Japan by NTT Docomo in 2001. 3G focused on standardized banders network protocol. In turn, users could access data from anywhere, which allowed international roaming services to begin. Compared to 2G, 3G had 4 time and data transferring capability, reaching up to 2 Mbps on average. Because of this increased video streaming, video conference and live video chat become real. Emails also become another standard form of communication over mobile device. What made 3G revolutionary though was the ability to surf the internet, basic HTML pages at that time, and stream music, on mobile. Although 2G did offer the same feature, they were not the advanced as what 3G had to term up the download speed and many other things. As the 3G era continued, improvement to the network increased speed and support. In the Canada, alone download speed was today are almost 6 Mbps. So although candy bar and flip phones were popular choices during the 3G era, smartphones were new. This new technology allowed users to listen to music, call, text, and search through the internet of the mobile devices. There were two major smartphone competitors at the time, BlackBerry and Apple. BlackBerry launched in first mobile device in 2002 and BlackBerry 5810. This smartphone offered a calendar, music, full keyboard, advanced security, and internet access. It was not until 2007 that was original iPhone came out, soon to dominate the smartphone and cell phone marketplace in the only few years. By 2017, BlackBerry market share was 0%. This was the released in 2008. The iPhone 3G or iPhone 2 paved the way for the smartphone today. Apple's cell phone demand was so high that 1 million iPhone 3G sold over the opening weekend. So, as smartphone become popular and the demand for the faster data uh, increase, the network capabilities was only few years away. Now 4G come, introducing the commercial use of Norway near the end of 2009. 4G offered today's standard services starting at minimum of 12.5 Mbps. 4G provided high quality video streaming, chat, fast mobile based access, yes, HD videos and online gaming. Compared to the simple SIM card switch from the 2G to 3G, mobile devices needed specifically designed to support 4G. However, when 4G first started, it was not actually 4G. When the ITUR set the required minimum speed for the 4G, it was not attainable at that time. The response to the amount of the money that tech manufacturer were putting into the achieving this goal, the ITUR decided the LTE long term evolution could be labeled as the 4G, but not if the provided a significant improvement over 3G. In short, 4G first came out what you were seeing was 3.9G and 3.95G instead. Today, that's not an issue of in by mid Canada launches first LTE wireless network in the Ottawa, Ontario, thanks to Rogers. This release offered speed just under the 12.5 Mbps, labeling it 4G LTE. Today's throw speed are faster in the today's 2020. During 4G region, the best selling cell phone include iPhone 6 and 22.4 million units and Samsung Galaxy S4 at 80 million units worldwide. The iPhone 6 left was Apple's best-selling smartphone to date, but the Samsung Galaxy S4 was also a trendy smartphone and the best-selling Android phone ever. Since the adoption in the 2019, 4G has just about reached its capacity in terms of data transferring speed. With the new technologies being introduced at the rapid pace, the world needs the faster network. 5G provides just that. 5G. South Korea was the first country to offer 5G in March 2019. The fifth generation was rolled out by KT, LG, Applus, and SK Telecom, all South Korean telecom providers. 5G in Canada has already been introduced in major cities. Some experts now claim that 5G will be 20 times faster than 4G. In fact, the median 5G download speed in Canada is 169.4 Mbps. That's already 205% faster than 4G. Another big difference between 4G and 5G is latency and bandwidth size. 5G latency is incredibly reduced, which increases the faster download and upload speed. Comparing the 4G has to be average latency of around 50 millisecond, whereas a 5G average latency is expected to the about 10. It is also possible that 5G could even drop down 1 millisecond of the latency. 5G also has a larger frequency range, supporting more technologies and serve devices. 5G is essential requirement of the mass the LOT deployment needed for smart cities and other industries. Even with the such potential, 5G has seen some backlash. Could electromagnetic hypersensitivity be the part of it? 5G more than just faster internet. This timeline from 1G to 5G brought us today. Although 5G hasn't launched globally yet, its new network capabilities will lead to the next digital revolution. 5G is so fast, only thinking about mobile uses quite limited. The next generation of wireless telephone, how 5G works and its feature in the 5G actually is a revolutionary how they're going to work, and 5G network is based on artificial intelligence will soon diagnosis the develop treatment for the better than your doctor could. So robots could wander the farmer fields, monitoring crop conditioning and harvesting grain. 5G is going to be future, and it will be more than just your phone. 5G is not just about faster mobile internet, but it is not quicker download speed either. 5G is a game changer, revolutionizing how we live and work in all industries. Not just one, it will change almost every aspect of our lives. So you need to wait for the 5G. For understanding more about it, go Great to Code website to learn more about new technologies and new features and new Internet of the Things. GSM network comprise the many means many the functional unit. These functions are interface as a GCM network can be broadly divided the mobile station, the base station subsystem BSS, network switching subsystem ENSS, operation support subsystem OSS, GSM the mobile station. The EMS station is consists of the physical equipment such as the radio receiver, display and digital signal processor, and the SIM card. It provides the air interface to the user in the GSM network. As such, other services and also provide which include voice teleservice, data bearer service, the feature supplementary service. This is the GSM phone. If you want to look on GSM SIM card, this is EMS function. The EMS also provide the repeat. EMS also provide the repeater so that user to voice data access. Moreover, the mobile facilities access voice messaging system. The EMS also provide the access to the various data services available in the GSM network. These data services include uh, these data services are include the connection to the paired speed, typically 9.6 kbps, and yeah. So now if you general pocket radio service like using either 06.25 or IP based data transfer method, speed like 115 kbs, and high speed circuit switches to the speed of the 64 kbps. The what is sim provide personal mobility so that the user can have access to all uh, subscribed service irrespective of the both the location and terminal, the specific terminal. You need to insert the sim card into the another GSM cellular phone to receive calls at the phone, make calls from that phone, and receive other subscribed service. So the GSM, the base station subsystem, the BS is composed of two parts: the base trans receiver and the base station controller BSC. The BTS and also the BSC communicate across the specific ABS interface, enabling operations between the components that are made by the different supplier. The radio that component of the BSS may consist of the 4 to 7 9 cell. The BSS may have one or more base station. The BSS use the ABS interface between the BTS and the BSC sphere is high speed line that is connected from the BSS to mobile EMSC. Now GSM basis BSS ABS and to EMSC high speed line. The base trans receiver station The BTS houses of the radio transceiver that define the cell and handles the radio link protocol with the EMS. In the large urban area, large number of the BTS may be deployed. Now you want to see the diagram of the GSM BTS. This is the diagram, this is the phone, this is the tower, and this is the another phone. So they are connected to the GSM BTS, and the one phone can connect with the another phone, this phone can connect to the another phone. So the BTS correspond to the transceiver and antenna used to each phone on the network. The BTS is usually placed in the center of the cell. Its transmitting power defines the size of the cell. Each BTS has between 1 and 16 transceiver, and depending on the density of the user of the cell, each BTS service as a single cell. It also includes the following function like encoding, transcoding, time, frequency, and voice through the full and half rate services, decoding, decrypting, and equalizing receiving signal, random access detection, time advances, uplink channel and measurement. The base station controller BSC. The base manages the radio resources, one or more BTS. It handles radio channel setup. The frequency hopping and handover. The BSC is the connection between the mobile and the MSC. The BSC also translates the 13 kbps voice channel used over the radio link to the standard used over the 64 kbps channel, and this is used by the public switched telephone network and ISDNs. It assigned and released the frequency and time slot element. The conditional frequency include control of the frequency hopping, performing traffic concentration, number of the lines from MSC, providing an interface to the operation and maintenance center for the BCSS, reallocation of the frequencies among BTS, time and frequency synchronization, power management, time delay measurement of the EMS, GSM, the network switching subsystem. Yes, the network switching system is the main part of the mobile switching center perform the switching of call between the mobile and other fixed or the mobile network user, as well as management uh, service such as authentication, BLR, AUC, NSS, MSC, HLR, EIR. So yeah, this is the something. The switching system include the following functional element: home location registers. So home location registers, the HLR is database used to storage and management of subscription. The HLR is considered the most important database as it stores permanent data about क्या अरविंद गुड मॉर्निंग. Now talking about home location register, the HLR, which we say the HLR is database used to storage and management of subscription. The HLR is considered the most important database as it stores permanent data about subscriber, including the subscriber service profile, location information, and activities status. When an individual buy and subscription in the form of SIM, then all the information about this subscription is registered in the HLR of the operator. Now, mobile service. Nothing is that mobile service is a switching center. Mobile service switching center. So the center component of the network subsystem is the mobile service switching center. The mobile service switching is the perform that switching of calls between the mobiles and other fixed or the mobile network users, as well as the management of the mobile service such as registration, authentication, location updating, handovers, and call routing to the roaming subscriber. It also performs network interfacing, common channel signaling, and others. Every MSC mobile serving switching is identified by unique ID. Now visitor location register. So the BLR. The BLR is a database that contains the temporary information about the subscriber that is needed by the MSC in order to service visiting subscriber. The BLR is always integrated with the MSC. When mobile station roam into the new MSC area, the BLR connected to the mobile station from the HLR. Later, if the mobile station make a call, the BLR will have the information needed for the call setup without having the interrogate HLR each time. I was just talking about the support system GSM. The operation and maintenance center OMS is connected to all the equipment in the switching system and the BSC. The implementation of OMC is called the operation and support system. Here are the some of the OMC function: administration and commercial operation, such like subscription, terminal chargings, and statistic. They also help in security management, so network configuration, operation and performance management, maintenance tasks. The operation and maintenance function are based on the concept of the telecommunication management network, which is standardized by the ITU-T series M.30. I mean, for this figure you are looking now, you can see this very good way. So this in the figure you can see that OMC system cover all the GSM element. So OMC, EIR, AUC and the BTS. These are one cell is connected to the mobile phone, mobile station, and these are connected to the BTS, BSC and MS. So the OSS is the functional entity from which the network operator monitors and control the system. The purpose of the OSS is to offer the customer cost-effective support for the centralized, regional and local operational maintenance activities that are required to GSM network. An important function of the OSS is to provide the network overview and support to the maintenance activities of the different operation and maintenance organizations.